Well, that was the script with science and faith. And speaking of science, we will now go into Quora, where we'll have a Quora about Jupiter. Everyone is asking, why is Jupiter a failed star? This used to be a common claim. Jupiter is a very large planet, and it was thought that if it was only slightly larger, it would be able to sustain nuclear fusion at its core and would become a tiny star, and our solar system would become a binary star system. This idea was promoted in the movie 2010 Odyssey 2, the sequel to the much more famous 2001 A Space Odyssey, where alien monoliths squeeze Jupiter until nuclear fusion is started, and the resulting small star enables life to develop on Europa, one of Jupiter's moons. In truth, even if you squeezed Jupiter hard enough to force nuclear fusion, as soon as you stopped squeezing it, it would explode because the force of its own light pressure would easily overcome its gravity. But that was fiction, and it was written before we understood all the facts about stars. Fact: the smallest theoretical mass for a star to support nuclear fusion is 0.07 times the mass of our Sun. Fact: our Sun weighs 2 times 10 squared 30 kilograms, so the smallest star would weigh around 1.4 times 10 squared 29 kilograms. Fact: Jupiter weighs 2 times 10 squared 27 kilograms. So Jupiter would need to be about 70 times more massive to become a star. Not even close. That said, if Jupiter was about 14 times larger than it is, it would be able to produce deuterium fusion at its core. But the resulting object would essentially be a brown dwarf, like a star that's run out of fuel. This is not the bright glowing thing you'd normally think of a star, but would generate heat internally, much as a star does, and it would glow very dimly in the infrared. As a confirmation of this, we now know of many exoplanets orbiting other stars that are much larger than Jupiter and which are not forming into stars. HR 2562b is the heaviest planet we know of. It's about 30 times more massive than Jupiter, and is essentially a brown dwarf. It glows with a brightness about 0.2% of that of a dim star. It would need to be a little over twice as massive to turn into a proper star. Dennis-P J082303.1-491201b, catchy name, eh? Is about 28 times the mass of Jupiter, and again straddles that line between a planet and a brown dwarf star. It orbits an actual brown dwarf, leading to some sources claiming that it's one of a pair of dying stars and not an overly huge, slightly glowing planet. Tough call. Conclusion: Jupiter would have to be more than 10 times the mass it actually is to stand any chance of being called a star, and even then it would be a disappointing brown dwarf that would not be the brightly glowing thing we'd expect of a star. It would have to be at least 70 times more massive to become a proper star. So I have to say, not even close. You're listening to the Saturday evening radio show with Alex Fox. And now we're going to play a song from the Dandy Warhols. Yes, the Dandy Warhols, the song is called Scientist. Here it is.